on follow. Where are they?
It's aggravating.
Okay, so as part of the art special interest group, basically people who in the club who are interested in art, specific everything, of course, is themed in terms of science fiction. So while I'm not, this perspective is not specifically science fiction, it's certainly applicable if you're doing science fiction art or any kind of art at all.
Excuse me.
So we would start with a blank page, and the first thing that you should be aware of is what's called the horizon line. And in simple terms, this is the divider between the land and the sky in any given image plane. Perspective is all about simulating a three-dimensional environment on a two-dimensional plane, which is your canvas or your piece of paper or whatever it is. So the first thing you need to be aware of is horizon line. A horizon line can be a low horizon line where you've got a lot of sky and a little bit less of land. So here's an example. There's your horizon line right there. And you can have a high horizon line.
Huh.
Here's another example right here.
So it is.
But we are going to stick with something more or less in the middle. Keep things simple. Next thing to be aware of is what's called the vanishing point.
Mm-hmm.
What is a vanishing point? Anybody know?
It's where everything converges.
Yep. Here's an example. Where's the vanishing point on this image?
The end of the rails.
Right, pretty much dead center here. This is where the train tracks. We know that the train tracks are however, I don't know what it is, 4 feet apart or whatever it is, 3 feet apart.
Right.
But it looks like they get closer and closer together the further away we get from our point of view. And the railroad ties as well seem to get narrower and narrower and eventually almost disappear in terms of the detail. And the trees are approximately the same height, but they also seem to diminish as you guys see the cursor when I'm doing this?
Yes.
Yeah.
Okay. So the vanishing point is that point on the horizon line where everything seems to converge and into a single point. Now we're going to do a simple exercise. We're going to do a room.
Oh, it's like a Necker cube. Well, not really.
Yeah. Well, this is a room. Floor, here we go. Floor here, walls and ceiling. And this is we have the single vanishing point here in the middle. It's called 1-point perspective.
Okay.
Now, thing about vanishing points is you can move the vanishing point anywhere along that horizon line, and that'll change the way your image appears. So you can shift a little bit over to one side. You can have a much narrower wall over on this side because of the steeper angle. And you can also drop down a little bit instead of standing. Your viewpoint being where a person is standing and looking at something, Maybe they're sitting down or kneeling.
Huh.
But we're not going to get too far into the weeds with all of that, so we're going to keep it simple. So we start by drawing a rectangle on our paper.
Okay.
This bottom line here, this horizontal line is you could call that your ground line. And these are the vertical lines. These are the two dimensions. These are the two dimensions that exist on a piece of paper.
Okay.
What we're trying to do is make it look like there's a third dimension, which is depth. So we have a grid here, and we can see there are each of these units of measurement, doesn't matter what it is, can be an inch, can be a yard, a meter, a mile, doesn't matter. Just each unit is equally a square, and we have 6 by 5.
Important question. Am I making too much noise?
Yes.
A little bit.
A little bit of noise, yeah.
I will just wash. Let me mute myself. Hold on. Go wash my hands and then dry them off. And then, where's the mute button? There it is.
Thank you, Danny. All right. Whoops. Okay, so what we want to do here is from our vanishing point, we want to draw a line to this corner over here, like so. And then we want to do the other 3 corners. So you've got all of the corners of our square connected to the vanishing point where the corner lines intersect. Further, you want to do the same thing from vanishing point to each point on your grid where the grid meets the edge of the square or the rectangle. We know that we have 3 units from vanishing point to the edge. So we're going to put a second vanishing point 3 units in this direction. Now we're right off the paper. And this is not unusual. There's no reason to panic. Often vanishing points are considerably off the paper. But in this case, we're able to do just to the edge of our image or screen here. And then we want to draw a line, a grid line from that second vanishing point to this nearest corner here. And then we're going to do it again to this first point where the grid intersects. And so on. At each point, you're going from your second vanishing point to your points on the grid where it intersects with the rectangle. Now, you'll notice that this point is where the line from our vanishing point and the line from our second vanishing point intersect. So we want to draw a horizontal line across our entire area there. Same thing from our vanishing point along this line to our second vanishing point. We want to do the same thing. So you end up with the beginnings of a floor happening. There it is. These lines I made them a little thicker than they normally would be, just so you can see them on the screen. Generally, you would be, if you're creating a grid, you would be probably using a large piece of tracing paper and doing your grid on the paper, and then overlaying that onto whatever whatever artwork you want to work on, and then that would be your guide to how to get the perspective right. A lot of artists they just know. I've always been pretty good at drawing in perspective without having to set up a grid and do all this kind of stuff. But some people have a difficult time with it. And if you're in the interests of absolute geometric accuracy, the grid might be the way to go. Okay, so we've got all our horizontals in. Now we go back to this point here, and we're going to run a vertical line from there up to this point. So again, this is the line from our vanishing point that intersects this top corner over here. And you want to do the same thing for the rest of the lines, and you end up with this. So now you're seeing a wall develop, and each of these units are geometrically accurate renditions of perspective. You then go up to the top here, and where this line meets this point, you do another horizontal line for all of these points, and that'll give you your ceiling, and then down again to meet up with these points down here. And that'll give you your other wall, and you end up with your finished room, which you can place objects in that room, and you would have that grid as a guide to make sure that the objects that you place in the room are also properly in perspective. So we go back to our, whoops, keep doing that. We go back to our original rectangle. Maybe we want to expand it a little bit. So the grid is now telling us that we have 1, 2, 3, 4. We have 8 by 5. So suppose we wanted to, now you're looking, when you're doing 1-point perspective, essentially you're looking straight on at an object. So we have a wall here. Suppose we wanted to put some columns along that wall, like this, maybe 4 columns, and you can see that they're equally spaced here. And you can check that with your grid, so you know that this column all corresponds on the grid. But now here's an interesting exercise and a little tip. Suppose that you have a perspective view of that same wall. You can't use your grid because it's inaccurate. This is a perspective view. So in perspective, the taller section, I'm pointing with my finger, but the taller section here, because of foreshortening, as we move further away from our point of view, it seems to get smaller. That's the railroad tracks getting narrow, and eventually, if you kept going along here, eventually you're going to get to, another another vanishing point way off on the right there. So this kind of a grid doesn't really help you. Even if you were to expand it, it's still not properly in proportion because these are equal distances, and perspective view would look like they're not equal distances in order to be correct. So what you can do is use a diagonal, and by doing the diagonal from corner to corner like this, creating an X, this point is dead center. Perspective, accurate, dead center. So you would draw a line through that. Now, if you look at this, you'll see that the distance between the edge and this center and this edge and the center are not the same. This one is a little bit smaller than this one. Again, that's perspective. That's foreshortening. So once you've started with that first line, you then have another section, another rectangle here, and you can do another diagonal in another line, and so on until you have all of your 8 units. So now you know where you're going to put your columns here, 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 and here, and still be in correct perspective. So that's called one-point perspective. Here's the vanishing point. So the road is converging here at the vanishing point. We know that these telephone poles are all the same height, but they appear to be getting shorter and shorter and shorter until they virtually disappear. Even the lines on the road narrow as they head towards that vanishing point. For something with a corner, if you're looking at basically a cube with a corner like a building, you might use 2-point perspective. That's vanishing points on either side of the building, off to the right and way off to the left. Those vanishing points would definitely be off the page. And 3-point perspective takes into account, if you're looking up at a tall building like these ones, the bottom of the building here looks wider than the top, even though not in fact. But you want it to look like a real image, a three-dimensional image. So here you have 3-point perspective, the third point being off up in the sky somewhere, which is where these lines would
If
converge.
you're doing science fiction stuff that's not on Earth, how does that affect perspective?
Perspective is perspective, but you could have multiple, like if you've got a bunch of spaceships, for example, free floating in space, they're not all necessarily, along the same line, along the same vanishing point, along the same plane, let's say. So you could have multiple um, uh, perspectives, uh,
That's, that,
each
that's not
each one tied to its own ship.
that's not really what I meant. I meant that you were like painting the moon or Mars, or like drawing the moon or Mars. The same thing works, even if the atmosphere or
If
it's
if you're
about how the
drawing
human eye sees it, not how the actual planet works.
Alexi, I think the point is that perspective is perspective because of the laws of optics.
Yes,
things,
that's what I'm saying. Is okay,
well,
yes,
in
that it
in
doesn't
in
change.
any draw in any painting or drawing, science fiction or otherwise, if you want it to look realistic, if you want it to look like the real thing would look if you were actually there on Mars looking out at the landscape or what have you, you got to take into account perspective. So if there's a Martian canal and you're standing at in the Martian canal and you're looking down the canal, perspective is going to be that vanishing point is at the far end of the canal.
And actually, there are no canals. It's the guy who's looking too strong into his telescope that he's
Yeah,
seeing.
Schiaparelli, yes.
Another example of vanishing point perspective kind of thing. The opening scrolling in most Star Wars films.
Yes. Yeah. The letters vanish into the distance. As yeah, because when I get out of the presentation here, we'll have a better conversation about that. Keep that thought. So perspective, back in the day, they didn't you really have
The concept.
the concept of linear perspective or geometric perspective. So they did have what they call hierarchical perspective, which means that the larger figures and the ones that are closer to the top tend to be the more important figures, whether spiritually or thematically or what have you. So here you have some looks like some kind of fishing or yeah, fishing going on, and everything is sort of on the same plane. There is some slight overlap from time to time, but it's definitely not perspective as we're familiar with it today. Here's another example from Turkey. So the larger figures are the more important figures, and the smaller figures are less along the hierarchy. But here you start to see some elements of perspective starting to creep in, and that's overlap. An object in front of another object is closer to you. So somebody standing right near you and somebody standing off in the background, you know that the person in the background is further away from the viewer, simply because the person standing next to the viewer overlaps that person in the distance. But you start to see some of that happening in art such as this piece. And you start to see elements of perspective. We just did the room there. So you see up in the ceiling area and these columns, a little bit of perspective. But the table that they're sitting around, that is off. It's off kilter. The perspective of this table doesn't match the perspective of the room that it's in.
Because they wanted to show what was on the table.
Yeah. But it's not in correct linear perspective.
No.
But they're getting there. It took over the course of probably pretty much the whole Renaissance era, and even before that. I mean, as far back as the ancient Greeks, they were trying to figure out how these things work.
But Keith, is it a
Architects,
question?
artists, mathematicians, everybody contributed. Yes, go ahead.
Well, is it because they didn't understand how to use it? Or is it because they weren't interested in using it? They wanted to show something else.
They didn't. It could be, depending on who you're talking about. It could be both. They hadn't figured out. I'll call it the scientific way of replicating reality on 2 dimensions.
Well, maybe not technically correct, but I've seen, children without the technical knowledge using perspective.
Yeah,
but very young children, like when I was teaching first grade, a fun thing is to ask them to draw their families. And you see these giant dogs and cats, like, bigger than their parents. Or you have a huge father and this tiny mother, or vice versa,
Yeah, well, I mean, as I say, with some folks, with some artists, it's almost you're almost born with it. You have an innate understanding of it, and you can do a drawing and look at it and say, oh, there's something wrong with this drawing, and it's often because the perspective is a little bit off. So you know how to go and correct it and make it look more realistic.
But maybe they wanted to show what was on the table.
Or that's true, like the hierarchical perspective is not really truly perspective. It's just a method of indicating on the piece of art that this person is important and this person not so much, for whatever reason, religious, royalty, one's a king and one's a peasant.
Or someone's dog, yeah, right.
when I was that old or that young and I was drawing, I would just start drawing, and after a while I realized they don't have enough space on the paper for everything, so the other things had to be small.
Yeah.
Kathy, also a lot of small children really do have giant dogs.
There is that.
Compared to that.
Yeah.
Yes, larger than their parents.
Yeah, little kids with a Saint Bernard. Hey, Linda.
Right.
Little kids with a Saint Bernard have giant dogs. An Irish wolfhound, they have a horse.
This also ties into, this is very interesting because this also ties into photography and different lenses, because you get different perspectives or distortions if you change the lens on your camera too.
Mm-hmm.
Yep, you can have like the fisheye. You get that fisheye effect where straight lines, what should be straight lines, seem to curve. And that's a photographic distortion caused by a particular lens.
Actually, because the fisheye lenses were really popular, say, in the 60s and 70s. But what happened, photographically speaking, was with computerized design, you started getting like super wide angle lenses. Yes, there would be some distortion, but nothing like the distortion of a fisheye lens. So the original fisheye lenses, the original wide angle lenses were pretty modest by today's standards. It was all calculated by hand. But the idea was, showing a broader than usual perspective of the world. Then along came the fisheye lenses, which were almost like I don't call it a stunt because they gave some interesting distortions. But then in the 80s, along came what they call super wide angle lenses. So let's say your 21, 17 millimeter wide angle lenses, which gave a very broad perspective and showed some distortion, but it wasn't like a truly insane distortion like the fisheye lens.
It wasn't as noticeable. Yeah.
Well, I mean, like things. Okay, because my widest wide angle lens is about 16 millimeters, and I think I've shown some pictures I taken with it where it distorts things from, let's say, front to back, but that's because of the increased depth of field. But it's not a deliberate total distortion of things for the sake of image effect, which is very much the thing in the 60s, but not nearly so much now.
The two streets on the side of the building, are they supposed to be parallel or are they supposed to meet later?
Which
You're going around the back of the building.
These streets here on each side?
Yeah.
Well, I don't know. I've never been. This is in Florence. So I don't know how far back those streets go. But
so is it a circle or is it straight lines, I guess?
They would probably, if they were continued as straight streets, at some point they would meet somewhere behind this building. And from the perspective view, they would seem to be converging into a vanishing point. So this particular building, as I said, is in Florence, Italy. It's a chapel, basically. And one of the guys who was involved with the development of perspective in art, he in the early 1400s, he came up with an experiment, and he did a painting or a drawing of that building in perspective, proper linear perspective. And then he had a person hold that painting up, and there was a hole in the painting that you could look through at the actual building. And so you're looking through this painting, and he had a mirror surface for the sky. So you were getting actual reflections of the real sky. But the drawing on that painting was a drawing of the building. So the person would be looking through this hole at the actual building off here on the left, and then you'd put up a mirror, and it would so then you would be looking at a mirror image of this painting that he did, and then he would ask people, "What do you see?" And in both instances, and they would say, "We see, the Florentine baptistry," because it looked right. The drawing looked like the building looked in real life. And this he was an architect. What was his name? Filippo Brunelleschi. Yeah. So there you go.
Is he the guy who built the building?
Sorry?
Is he the guy who actually built the building?
No. Actually, the building, when he did this experiment, the building was still under construction. So, and a final word on perspective. We have something called aerial perspective or atmospheric perspective. And that is the tendency, because of the way light travels through the atmosphere, you get that bluish, hazy look in the distance.
Mm-hmm.
There's more color and more detail in the closer areas, but as you move back through the picture into the distance, things get bluish. And that's merely because of the way light is refracted through the atmosphere.
Would that be different on a planet with less oxygen?
I guess it would be a little bit different.
Or on the moon.
No, it's not because of oxygen.
Be more nitrogen.
Because of the way the light refracts.
I mean,
It
here,
doesn't have
there's
to be oxygen, like
there's
It looks more like
particulate.
gas.
a misty place.
There's a particulate matter in the atmosphere and so forth. There's a lot of. The point is, here on Earth, which is where we all are, and where these techniques were developed. If you want to make a painting of the mountains, or the valley that you're vacationing in, and the mountains in the distance, you're to get it to look right. You're going to want to get a little bit of blue into that middle and distant background.
It's probably the same blue you get when you look at the sky.
That's
Yeah.
right.
Yeah, exactly. Yeah.
You suppose if you were on Mars, if it would go would it go in orange or something?
Yes, it's reddish.
Yeah.
Yeah, probably, yeah.
Well, photography.
Having never been on Mars.
Yes, but we have robots
But
on
we
Mars,
have-
and
we
their
have-
pictures are reddish.
If you have,
Atmosphere's
you've
reddish.
seen pictures of, although those pictures tend to be like close-ups of rocks and stuff. But
No, there are some of the sky, and it is reddish.
Yeah, it goes hazy the same way, but reddish. And photography on the moon has shown it stays sharp the whole way. There's no distortion.
Mm-hmm.
Yeah, good point.
It's the atmosphere.
There's no atmosphere on the moon, so yeah.
I think there's technically a very small amount of atmosphere on the moon. Technically, can't look that up now. Lunar atmosphere.
On the sunny side, yes, because there's some ionization that pushes dust over the surface, so it creates a very thin atmosphere.
Yeah, 0.3 nanopascals, 3 times 10 to the minus 15 atmospheres. So technically yes, but practically no.
Any questions on perspective?
But wait, how can you possibly have atmosphere on only one side of the planet? That doesn't make sense. But that's what you said. It can't possibly be right.
Yeah,
Because you've got the heat of the sun.
No, it's the light hitting the sun ionizes some of the dust, which by repulsion pushes it up. On the dark side, there's no more ionization, so it falls back down.
It's a question of, do you consider that atmosphere? Technically, yes. Practically, no.
Well, I wouldn't want to, try breathing there, so without a suit. So here, for example, we have a box of Kleenex, right? I'm going to see. Now, if you're looking at that straight on, it's a rectangle. But if you're looking at it from a certain angle, it's not a rectangle anymore. It looks more like a square. And it's wider here, closer to you, than it is back here, further away from you. So this is just the physical reality of the world in which we live. And all of these mathematicians and artists and architects were trying to figure out a way to represent that on a two-dimensional piece of paper when they were doing artwork. And
that was a very interesting presentation, Keith.
That's our art lesson for the day. Okay.
Cool.
Any final questions, and then we'll go to break, and then the reports.
Regarding the
Lunch just beeped. Sorry.
Okay, go ahead, Hendrik. You had a question? No? Okay. Somebody started to say something there.
Yeah, regarding the haze effect, is that the same effect that we see when you look at the skyline from afar and you see the lights a little bit?
Yeah, the way light plays in the atmosphere as it's coming into the atmosphere.
Okay.
Creates effects, visual effects, and as an artist, if you're looking to realistically or quasi-realistically represent, a landscape, let's say, or a cityscape, you got to take that into effect.
Okay. Thank you.
or you got to take that into consideration when you're doing your piece. Okay, so we've done perspective, and we've done how to create sci-fi art without knowing how to draw. So I don't know. I'll give it some thought and come up with some more art.
What was that
special
about how to
interest group
create
stuff.
science fiction
Sorry,
art without
I
creating the
didn't hear.
science fiction art?
Sorry, say that again.
The question of how to create science. I was watching about perspective. How to create science fiction art without knowing how to draw. Did I miss something?
Yes, the first special interest group we had, I guess it was last year now, um, was basically, you know, creating things like digital collages and everything.
Oh
So
yes, that. Yeah. Gotcha.
taking photographs and,
No, understood.
you know,
I remember now. Yes.
okay, that's what I meant. But you don't have to necessarily know how to draw, but you do have to have something of an understanding of you know how things appear in a
Or just
given,
ask the AI to do it.
or yeah, well, there you go. I mean, these days it's getting to the point where, you know, at least in the advertising field, which I used to be in many moons ago before I retired, um, you know, you used to hire an artist to draw whatever it was. You know, if you had a piece of furniture or something that you were selling, you would hire an artist to draw that. Now you just have to tell the AI, I need, you know, a drawing of this piece of furniture, describe the piece of furniture, and it does it in seconds.
Or well,
So
it does several things
it
that
is
look sort of like it.
it is disruptive in the sense that at least in the advertising art game, um, it's going to put people out of work because it'll no doubt be cheaper to, you know, just talk to your AI. If you have a small company and you want to do, you know, an advertising flyer or whatever.
This is turning out to not be as effective as they thought, really.
Yeah,
because the AI isn't genuinely or accurate.
I mean, it's getting to the point where it's good enough that it's going to take some jobs away. You know, depending on, I mean, if you're, you know, if you're doing like a sales catalog and you just need like little sketches of little, I mean, I did a job like this for, you know, many years ago now for a company that produces um, plexiglass, you know, lamps and lighting fixtures and so forth. So I would, before they even had built one, they would say, we want to, you know, here's what we want to, what we're designing. They'd show me the plans. I would do an isometric view of the thing that doesn't yet exist because they haven't, you know, the shop hasn't built a prototype yet. And they would go out and you know, put that in their catalog and use it to sell the piece. If there was enough interest in it, obviously they'd include it in their line. So you would hire artists like me to do that kind of thing. Um, Nowadays, you could probably just, you know, get the AI to do it for you, and it would be acceptable enough that it would do the job that you're